All right. Now we're going to go over some problems from my website, ottslearning.com, that regard to 1.2 or scientific notation, the standard for that one. Now, these problems are going to encompass some of 1.1 as well, so you want to make sure that knowledge is rock solid in your head. I have PDFs and videos for that as well on my website, so feel free to check those out. I'm only going to be going over a few problems because the others you can check out on yourself. These are the more harder problems, I deemed. And if you're working through these problems with me, you want to make sure that you have to use only a simple non-scientific calculator, okay? Because lots of times scientific calculators do it for you. They do the E times 10 to the thing, and then they give it to you. But you want to practice doing this by yourself, not use it with the calculator, right? So make sure you're using a simple calculator, or you can use a scientific calculator, but don't use scientific functions. Only use it for basic arithmetic. So let's go over problem 3. Multiply 3.2 times 10 to the 5 times 4.0 times 10 to the negative 2. Okay. So show the unrounded product before you simplify it, then give your final answer in proper scientific notation. So remember, A times B is what happens when you multiply scientific notation times 10 to the m plus n. A times B is 3.2 times 4, right? 4.0, which gives me 12.8 times 10 to the 5 minus 2, or 10 to the third. But this isn't my final answer because you have to renormalize it, right? Remember, this doesn't fit my constraints for the A value, which has to be greater than or equal to 1 and lower than 10. This is greater than 10, or at least a magnitude of A. So how do I fix this? Well, I can divide by 10 here, right, to make it 1.28. But in order to keep that balance, I need to multiply by 10 here, so it becomes 10 to the 4. Okay? Or another way I could do it is, I could look at this, I could see, I need to shift the decimal point 1 point this way. But then this becomes a smaller number. I need to make this larger in order to keep the balance, right? I can't have this become smaller and this stay the same. So I would become 1.28 times 10 to the 4, right? Yeah. Now let's go over problem 7. Okay. Actually, problem 8, sorry. Capacitor stores a charge of 0.000091 coulombs. A technician needs this value logged in microcoulombs. If you remember, micro prefix represented 10 to the negative 6. And this should be written in scientific notation. Convert the unit and format the notation correctly. Your final answer needs both parts right, not just one. Okay, so first I convert these coulombs to microcoulombs. How do I do that? Well, micro is 10 to the negative 6. Okay? And then what is this? How many zeros did I go backward? I went 1 0 backward, 2, 3, 4, 5. And then my 9 went backward one more. Remember, you start with scientific notation here, right? At the left. And then you count how many zeros backward you went, or how many places backward. In this case, 1, 2, 3, 4, 5, 6. And then 7. Right? So then what happens? It becomes 9.1 times 10 to the negative 6, because there's 5 zeros here, and the 9 was the last place, right? So if you imagine the 9 can shift for that, right? It then becomes 10 to the negative 5, and then you add 5 zeros to replace, to move the 9 adequately back. And then this is microcoulombs, right? Because what do? We moved it back that way. And since it's microcoulombs, we have to change the 10 to the negative 6. Because we know micro represents 10 to the negative 6. We don't need another 10 to the negative 6. So it just becomes 9.1 microcoulombs. Okay? Or, yeah, 9.1 times 10 to the negative 6 coulombs. Yeah, you just count the zeros, right? And how many places the 9 traveled, because 9 is the main value. Because I need a non-zero digit right here. So it becomes 9 times 10 to the negative 6 coulombs. Now let's move on to problem number 10. Right. So as always, right, pause the video and take a try on it by yourself, because that really helps you more than just watching this. Okay. So now let's work through this together. The table below lists the masses of 4 objects, each given in a different unit. Convert every mass to kilograms, express each in scientific notation, then list the 4 objects in order from lightest to heaviest. So I convert them to kilograms first, right? So remember, a kilogram was equal to 1,000 grams. So this would be 4 times 10 to the, see how many zeros it shifted? 1, 2, 3, 4, 5, 6, 7. Times 10 to the negative 7 grams, right? And then you use the conversion factor, 1 kg over 1,000 grams, because you want to cancel out the grams to be left with kgs, right? So then this becomes 4 times 10 to the negative 7 over 10 to the third, because of 1,000 kgs, or just 4 times 10 to the negative 10 kgs. All right, then this milligrams, 28 milligrams, is basically 2.8 times 10 to the negative 3 grams, right? If you remember, the prefix milli was 10 to the negative 3. So this becomes times 1 kg over 1,000 milligrams, or over 1,000 grams, sorry. Cancel those out. Becomes 2.8 times 10 to the negative 3 over 1,000. So it becomes 2.8 times 10 to the negative 6 kgs. Right? I'm just going to write those over here so it's more easy to look at. Okay. Now an apple is 180 grams. So 180 grams times 1 kg over 1,000 grams. Cancel these out. Becomes 0.18 kgs. Or you can write it as, because you want it in scientific notation, right? So you move this back 1.8, and then if you increase this, you have to decrease it adequately, right? Times 10 to the negative 1 kgs. Because if you increase this number, you have to decrease it. Otherwise, it'll change the value. You want to keep it in scientific notation, so you want this 0 to become a 1, or the next digit, right? Non-zero digits. Adult cat weighs 4.5 kgs. That's good as it is. 4.5 times 10 to the 0 kgs. In order from lightest to heaviest. And it looks like this order is good, right? Because 10 to the negative 10, the order of magnitude is lowest. Because, you know, it's going to have the most zeros. It's going to have around 10 zeros, on and on. So this is the lightest. This is the second lightest because it's going to have 6 zeros and then a 2. 1 0 and then a 1. So it's 0.18, right? And this one is in the positives. It doesn't have, sorry, not positives, but greater than 1. It's not in the decimals. So this order is already correct. Now, let's go over problem number 12. Okay. Graph 2 shows the population of 4 bacteria samples on a logarithmic scale. From the graph alone, estimate the order of magnitude, nearest power of 10. of sample A's population and sample B's population, right? So you look over here, and then you look at which one seems to fit these two. So this one is 10 to the 5th because it's closer to 10 to the 5th, right? And it's not over 10 to the 5th. And it is over 10 to the 5th, but it's not over 10 to the 6th. It doesn't cross over that. Only if it crossed over it, so like 2 times 10 to the 6th, then that means it would be larger than 10 to the 6th, right? Otherwise, it's lower than that, so it's going to be like 9 times 10 to the 5th. But that's still fine. That's still in the order of magnitude of 5. So this is something times 10 to the 5, which means its order of magnitude is 5. So for question A, B's order of magnitude is 5, and A's is similarly. It doesn't cross 4, so it can't have something like A times 10 to the 4. So its magnitude is not 4. It crosses 3 though, so it's going to be 3. What's the lab's precise instrument readings for C? Well, they gave us that. That's 8 times 10 to the 4. So that's nice of them to give us that. And sample G is, 2 times 10 to the 6 bacteria. Calculate exactly how many times greater sample D's population is than sample C's population. How would we calculate that? Well, we need to find out what you'd multiply this by to get to this, right? Or in other words, we need to divide this by this. So 2 times 10 to the 6 divided by 8 times 10 to the 4 becomes 1/4, or in other words, 0.25, like A divided by B, remember? Times 10 to the m minus n. So times 10 to the 6 minus 4, which is 2. Okay? And then they didn't specify whether we need to write this in scientific notation. So you could write it as, if you increase this to become 2.5, you have to decrease this, right? Times 10 to the 1. Or you could just write it as, regularly 25, because they didn't specify. So it's 25 times greater than that. All right? Now, the last problem is problem number... Actually, let's go over problem 13 as well. The table lists the average distance from the sun to 4 planets in kilometers. Identify the third closest planet to the sun using the table, then convert only that planet's distance to meters and express it in scientific notation. Okay. So we know this is going to be the largest distance from the sun, right? We want the third closest planet to the sun, which means, in other words, so if we had these two, right? If we said had large, semi-large, small, and very small, then it would be this one, right? Semi-large, which is the only planet that has a distance, that has a second largest distance, let's say that. Okay? Or actually, if you imagine a planet, so I think I might have been going about this problem wrong. If you imagine a planet, multiple planets, right? The third closest planet is going to be the semi-large planet, yeah. Because you can see over here, 1 is the lowest distance, 2 is the second lowest distance, 3 is a semi-large distance. So I need the second largest distance. Or in other words, this one, because 22,000 or 227 is the largest, but Earth is just 149, which is what we need. It's between Venus, which is just 108, which is lower than Earth, which means it's the second. This one is the lowest, so lowest, second lowest, and third lowest. Okay? And then we need to convert this planet's distance to meters, and express it in scientific notation. So if you look at this, first we notice it's in kilometers, right? So let's convert it to meters. We know 1 kilometer is equal to 1,000 meters. So we just have to multiply this by 1,000 meters over 1 kilometer. The kilometers cancel out. We're left with 149,600,000,000. So, and then meters, because the kilometers cancel out. Obviously, it'd be very efficient to represent this in scientific notation. You can already see that, right? As always, I start from the left. I take the first digit, which is 1 point. I take all the non-zero digits, 4, 9, 6. And then I count how many places I am away from my 1. How many places are after my 1? 4, 9, 6, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 10 to the 11 meters would be my answer. Okay, and I can verify this. So it would become 1496 times 10 to the, so I move 3 places, this would become 8. So that means I have to have 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, which matches up. All right. Now let's go over problem 15. So the graph shows us the energy released by 4 earthquakes plotted on a logarithmic scale in joules. Okay, they gave us a few precise readings, and we'll see where we get to use that. Calculate exactly how many times more energy earthquake 2 released than earthquake 4. So, same process as the previous question, right? You have to divide earthquake 2's energy by earthquake 4 to get the amount of times greater it is. How much you have to multiply to get to earthquake 2, because earthquake 2 is larger. So question number A, I write it down here, and let's work through it. Over 9 times 10 to the 9. Remember, this is A divided by B times 10 to the 12 minus 9, or 10 cubed. And then 6.3 divided by 9, you can use a simple calculator, right? Like I said, you get 0.7 times 10 to the 3. And then there's no joules or anything, because you see the units, the joules here, cancel out. So this is just a magnitude ratio, how much greater it is. So if you were to replace this from scientific notation, because this doesn't need to be in scientific notation, right? Becomes 7. You've shifted 1 place, times 10 squared. And then you can add 2 zeros, or 700 times greater. 700 times greater. Now B is asking, convert earthquakes 4 energy to kilojoules and express it in scientific notation. Earthquake 4 is 9.9 times 10 to the 9 joules, right? Now, kilojoules, always remember 1 kilojoule or 1 kilo anything is 10 to the 3rd or 1,000 times the regular unit, so 1,000 joules. Cancel the joules out here, becomes 9.0 times 10 to the 9 over 10 cubed, right? Which gives us 9 times 10 to the 6 joules. Or, sorry, kilojoules. Now, I'm going to use this. Let me just go over here because I don't got much space there. I need to convert this to scientific notation, which it seems like it's already done, right? I didn't multiply this all out. I kept the 9.0 like it is because I had a feeling that that would come in handy, which it did. So now I can just write this as 9.0 times 10 to the 6 kilojoules. So A is lesser than or greater than or equal to 1, right? So it's greater than or equal to 1. 9 is greater than or equal to 1, and it's lesser than 10, so it's good. Now, this is the last problem we're going to go over. If you can solve this problem, consider yourself good for both 1.1 as well as 1.2. Okay? So we have to use graph 1 again, it seems, the drone distance graph from problem 9. A second drone B, travels at a distance of 2.56 times 10 to the 7 centimeters during the same test window. Determine drone A's distance at t equals 100 seconds from the graph 1 in kilometers. So drone A, we don't have that, right? They give us a drone B. I'm assuming drone A is in problem 9. So if I go up, we can see here, drone A, what's it telling us? Drone A at 100 seconds is up here, which is 160, and then kilometers. Always remember to read the units. So if I go back down, I can write down 160 kilometers. And they let me keep it in kilometers over here, right? And I want to convert drone B's distance to kilometers. So they gave me a distance of 2.56 times 10 to the 7 centimeters. So I don't have a ratio for kilometer to centimeters, so I'm going to make one. Kilometer, hectometer, decameter, meter, centimeter, decimeter, centimeter, and millimeter. So how many places am I skipping from kilometer to centimeter? 1, 2, 3, 4, 5. So 1 kilometer is equal to 10 to the 5 centimeters. Because if I go downward, I have to multiply by 10, right? If I go upward, I have to divide by 10. So it becomes 10 to the 5 centimeters. Cancel out the centimeters. 2.56 times 10 to the 7 divided by 10 to the 5. And then you can see this becomes 2.56 times 10 to the 7 minus 5, or 10 squared kilometers. In other words, this is 256 kilometers, right? We don't need to write in scientific notation. They didn't ask for that. So I could make it a bit easier to read. Okay. Now find the positive difference between the two drones' distances. Convert that difference to meters and express it in scientific notation. Okay, so they want us to basically subtract them and find out how far they are. 256 kilometers minus 160 kilometers. So now, because it's getting a bit messy, I'm just going to box my answers so you know which ones are the answers, right? This gives us, it should give us 94, or actually 90, it should give us 96 kilometers, yeah, because this just sits here. The 94 would be if we are adding this. Now we want to convert this distance to meters. So we know that, I shouldn't box this because I only boxed my answers, right? Kilometers times 1,000 meters over 1 kilometer. Cancel out the kilometers, I get 96,000 meters. And then I express it in scientific notation. As always, I start on the left, take the first digit, make every non-zero digit after it a decimal, so 9.6, times 10 to the how many digits are after it? 1, 2, 3, 4 meters. Okay? Now, I also want to state the order of magnitude of that difference, which means the nearest power of 10, right? But be careful here, okay? The order of magnitude is always, I round this number first, and then I can find the order of magnitude. So I would round this to be 10 to the 1 times 10 to the 4. So then this becomes 1 times 10 to the 5. And my order of magnitude would be 10 to the 5. And the order of magnitude doesn't need any units because it's just a representation, right? So that's my hard practice problems on odds. If you want to look at the other problems, you can obviously open up my website, oddslearning.com, and then take a look at those. Okay? I have other practice problems and other PDFs as well as other videos if you need help on it. Feel free to check out my channel as well as my website and give me a like and subscribe if you believe I helped you. Thank you for listening.